Cloud computing. Cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence, over the Internet, the cloud, to offer faster innovation, flexible resources, and economies of scale.
Types of cloud computing. Public cloud. Public clouds are owned and operated by third-party cloud service providers, which deliver their computing resources, like servers and storage, over the Internet. Microsoft Azure is an example of a public cloud. With a public cloud, all hardware, software, and other supporting infrastructure is owned and managed by the cloud provider. You access these services and manage your account using a web browser.
Private cloud. A private cloud refers to cloud computing resources used exclusively by a single business or organization. A private cloud can be physically located on the company's on-site data center. Some companies also pay third-party service providers to host their private cloud. A private cloud is one in which the services and infrastructure are maintained on a private network.
Hybrid cloud. Hybrid clouds combine public and private clouds, bound together by technology that allows data and applications to be shared between them. By allowing data and applications to move between private and public clouds, a hybrid cloud gives your business greater flexibility, more deployment options, and helps optimize your existing infrastructure, security, and compliance.
Types of cloud services/cloud computing models. Infrastructure as a service, IaaS. Infrastructure as a service is a form of cloud computing that delivers computer infrastructure. This includes servers, storage, networking, and data center space on an on-demand basis. IaaS services are typically charged on a pay-as-you-go basis. IaaS services is provided by Windows Azure, Google Computer Engine, etc.
Platform as a Service, PaaS. Platforms as a Service is a cloud computing model in which a service provider delivers a platform for developing, testing, deploying, and managing applications in the cloud. Common features of PaaS solutions include web hosting, database management, and application development environments. PaaS service providers are Force.com, Google App Engine, etc.
Software as a Service, SaaS. SaaS is a service that delivers a software application to users. Typically, SaaS apps are web applications or mobile apps that users can access via a web browser. SaaS also eliminates the need to have an app installed locally on each individual user's computer. SaaS service providers are Microsoft Office 365, Google Apps, etc.
Applications of cloud computing. Online data storage. Backup and recovery, big data. Testing and development. E-governance. Entertainment.
Advantages of cloud computing. 1. Cost efficient. 2. Almost unlimited storage. 3. Backup and recovery. 4. Easy access to information. 5. Quick deployment.
Disadvantages of clouding computing. 1. Technical issues. 2. Security in the cloud. 3. Limited control. 4. Internet connectivity. 5. Data portability.
Big data. Big data refers to complex and large data sets that have to be processed and analyzed to uncover valuable information that can benefit businesses and organizations. Big data is a collection of data that is huge in volume, yet growing exponentially with time. It is a data with so large size and complexity that none of traditional data management tools can store it or process it efficiently. Big data is also a data but with huge size. Big data is a combination of unstructured, semi-structured or structured data collected by organizations.
Some sources of big data are social media, stock exchange, e-commerce, weather station, telecom company.
Features of big data. 1. Velocity. Velocity refers to the speed of data processing. High velocity is crucial for the performance of any big data process. It consists of the rate of change, activity bursts, and the linking of incoming data sets.
2. Volume. Volume refers to the amount of data that you have. We measure the volume of our data in gigabytes, zettabytes, ZB, and yottabytes, YB. According to the industry trends, the volume of data will rise substantially in the coming years.
3. Value. Value refers to the benefits that your organization derives from the data. Does it match your organization's goals? Does it help your organization enhance itself? It's among the most important big data core characteristics.
Four. Variety. Variety refers to the different types of big data. It is among the biggest issues faced by the big data industry as it affects performance. It's vital to manage the variety of your data properly by organizing it. Variety is the various types of data that you gather from different kinds of sources.
5. Veracity. Veracity refers to the accuracy of your data. It is among the most important big data characteristics, as low veracity can greatly damage the accuracy of your results. 6. Validity. How valid and relevant is the data to be used for the intended purpose?
7. Volatility. Big data is constantly changing. The data you gathered from a source a day ago might be different from what you found today. This is called variability of data, and it affects your data homogenization.
8. Visualization. Visualization refers to showing your big data-generated insights through visual representations such as charts and graphs. It has become prevalent recently as big data professionals regularly share their insights with non-technical audiences. Types of big data. 1. Structured. Structured data refers to the data that you can process, store, and retrieve in a fixed format. It is highly organized information that you can store and access from a database by using simple algorithms. This is the easiest type of data to manage as you know what data format you are working with in advance. For example, the data that a company stores in its databases in the form of tables and spreadsheets is structured data.
2. Unstructured. Data with an unknown structure is termed unstructured data. Its size is substantially bigger than structured data and is heterogeneous in nature. A great example of unstructured data includes the results you get when you perform a Google search. You get web pages, videos, images, text, and other data formats of varying sizes.
Three, semi-structured. As the name suggests, semi-structured data contains a combination of structured and unstructured data. It is data that hasn't been classified into a specific database but contains vital tags that separate individual elements within the same. For example, a table definition in relational DBMS has semi-structured data. Application of big data. Banking and securities. Communications, media and entertainment. Healthcare providers. Education. Manufacturing and natural resources. Government. Insurance. Retail and wholesale trade.